Welcome to This Explainer. Today, we're diving into a truly wild intersection where raw biology literally crashes headfirst into computer science. We're unpacking the digital pathology of code. And honestly, it might just completely change how you look at a computer virus forever.
Okay, let's dive into this. So, what on earth connects Al Capone's brain to that computer sitting on your desk right now? I know, it sounds like some bizarre historical joke, right? But bridging this massive knowledge gap requires us to completely shift how we view modern technology.
Let's move into Section 1, the digital organism, code as a pathogen. So the crucial point here is how we perceive code. We usually think of it as passive, right? Just sterile lines of abstract math. But the concept of a digital organism is a radical reframe. We're talking about code that replicates and hijacks hosts exactly like biological DNA. It literally operates with a biological imperative to survive and to spread.
Which brings us to Section 2, malware equivalents, biological patterns.
Whether we are talking about a human body or a massive computer network, the infection process follows a virtually identical path. Step 1 is exposure. That's where the entity breaches the perimeter. Step 2 is replication, where it multiplies just to ensure its own survival. And finally, Step 3, hijacking the host's resources for its own benefit. Now think about the natural world. Certain pathogens don't even need a vector. They just spread independently through the air or water to find new, unsuspecting hosts. Well, computer worms follow this exact same biological pattern. They don't need a user to click a file or open an email. They actively crawl through networks entirely on their own. But contrast that with viruses that use deceptive entry. You know, the ones mimicking healthy proteins to trick a cell into opening its doors. That is precisely how a Trojan operates. It masks itself as a perfectly legitimate program, basically tricking the user into bypassing their very own firewall.
And then, of course, we have the stealth variants. Think of asymptomatic biological diseases, the ones that spread so quietly, leaving almost zero outward trace. Fileless malware is the absolute perfect digital equivalent here. It operates entirely in the system's memory, leaving absolutely no trace on the hard drive. It's practically invisible.
Let's move to and see how this builds in Section 3, Al Capone infection, the terminal stage.
A rootkit isn't just a digital common cold. No, it is the neurosyphilis of the digital world. It's this incredibly severe, late-stage disease that completely fundamentally alters the baseline behavior of the host. And this brilliantly illustrates the concept of the kernel, the literal core of any operating system. Just as a biological infection becomes deeply entrenched when it reaches the brain, a rootkit embeds its way right into the kernel. It hides in the very brain of your computer. And once it's in there, it is practically impossible to remove. Now, tying it back to real life, Al Capone famously suffered from late-stage neurosyphilis. This biological disease absolutely ravaged him, eventually reducing his mind to that of a 12-year-old child. His cognitive functions, his history, his memory, they were all entirely taken from him.
And just as Capone's memories were biologically locked away, a digital system infected by ransomware is completely paralyzed. Its files, its history, its memory, they are literally locked and held hostage. It reduces the machine to this blank, totally unusable state until a hefty price is paid.
Which brings us to our final part, Section 4, digital pathology, the prognosis.
Now, what's really interesting here is how perfectly the digital world mirrors these visceral biological realities. Code operates exactly as a replicating digital organism. Rootkits hide deep, deep down in the kernel, much like neurosyphilis, and ransomware locks away memory, perfectly mirroring that tragic cognitive decline. The parallels are just absolute.
So code is not just math. It is literally an infection, just waiting for a host. When we finally start treating cybersecurity with the exact same pathological seriousness as human biology, well, that's when we begin to actually comprehend the true nature of the threats we face online every single day.
Which leaves us with a pretty massive question. Just how vulnerable is your own digital DNA? Seriously, think about the devices you use every single day, the precious memory they hold, and the invisible organisms they're constantly exposed to. I really hope this explainer has completely shifted your perspective on the living code all around us. Stay curious, stay vigilant, and we'll see you next time.